All right. Problem 19. We have y is equal to the square root of 3 over 3x. And this is the whole idea with polar equations is that you got to recognize. Yes, Kaylin? Oh, freeze. Right. Before I start. All right. So y is equal to root 3 over 3x. And the whole idea with polar equations is that you try to recognize the type of rectangular equation is, and that helps you get familiar with what a polar equation is going to look like. All right. So this is a line, and line is one of the few polar equations where in polar it's represented as it's represented by isolating theta. All right. So if y is equal to root 3 over 3 times x, what we can do is we can manipulate our polar formulas, which, as a reminder, our polar conversion formulas are going to be x is equal to r times the cosine of theta, y is equal to r times the sine of theta, r squared is equal to x squared plus y squared. All right. R is equal to the square root of x squared plus y squared. The tangent of theta is equal to y over x. And theta is equal to the inverse tangent of y over x. All right? All right? So, with all our formulas in mind, what we can do for a line is represented by an angle. So, we can divide each side by x here. The x's will cancel out, and we will have y over x is equal to root 3 over 3. And one of our polar conversion formulas is that the tangent of theta equals y over x. So we can replace our y over x with the tangent of theta. So for our next line, when we're doing our math, we can write the tangent of theta is equal to the square root of 3 over 3. All right? And to find theta, because we're trying to isolate theta right here, we can find the inverse tangent of each side. So theta is equal to the inverse tangent of, is it going on YouTube? Or not? It's coming. The inverse tangent of root 3 over 3. Okay? So from your unit circle, the inverse tangent of root 3 over 3, all right, should be pi over 6. So theta should be equal to, from the unit circle, pi over 6. All right. Another acceptable value is if you add pi to this. Remember, that's equal to pi. Theta could also be equal to 7 pi over 6. So these are your two values for theta. And one thing you could do is you could just plot the line, like just draw the angle 7 pi over 6 going through the origin, or pi over 6 going through the origin in all directions, and it's going to be in the same position as y equals root 3 over 3.
I have to know about polar.
Okay, cool. All right, so that is a polar line. What we have to do is manipulate the equation so you have y over x, replace tangent theta with y over x, take the inverse tangent of each side, and then know the unit circle so that we have theta is equal to pi over 6. If you don't have your unit circle memorized for whatever reason, all right, you can know that pi over 6 you could find the in radian mode, because we are dealing with radians. Okay, you could find the inverse tangent of pi over so the inverse tangent of root 3 over 3. Alright, that's going to be 0.523, and that should be equivalent to pi over 6. If we do pi divided by 6, that gives us the same answer. So that shows us that those equivalent. So if you spit out if your calculator spits out a decimal and you don't have the unit circle memorized, you can just take your answer choices, evaluate them, and learn that pi over 6 is 0.523. Alright. Alright. For 20, y is equal to negative 2x plus 1. So here, what we can do is use our polar conversion formulas. So y is equal to r sine of theta. Remember, y is equal to r sine of theta, which is equal to negative 2, x is r cosine of theta, plus 1. Our next job here is going to be to subtract negative, is get everything on the same side. So we have r sine of theta is equal to negative 2, r cosine of theta, plus 1. All right? Our next job is to add 2r cosine theta to each side. So we have r sine of theta plus 2r cosine of theta is equal to 1. So these are going to cancel out. At this point, you have r sine of theta plus 2r cosine theta is equal to 1. And now you can factor out an r. And for most polar equations, for the vast majority of them, your goal is to isolate r. So we can factor out an r and get the sine of theta plus 2 times the cosine of theta is equal to 1. And then lastly, to get r by itself, we can divide each side by the sine of theta plus 2 times the cosine of theta. So we can divide this side by the sine of theta plus 2 times the cosine of theta. Put those all in parentheses. So r is equal to 1 over the sine of theta plus 2 times the cosine of theta. Alright, so I'm going to box, let me box that in red. So that's my answer for number 20. Alright, that finishes out the section. And then let's go on to the next section.